Okay, so 2, 5, -7, -3. How many zeros do I have? Mr. Fontecchio.
You have 3 zeros.
3 zeros. They might disappear in pairs because they're imaginary. So they're looking for real ones. I might have 3 or 1. How many would be positive?
2.
2. How many sign changes do you see?
Oh, wait, only once.
1 positive, therefore 2 negatives, or maybe no negatives. Those are my options. So now I'm going to start guessing some numbers. Now, I'm a lazy person, so I'm going to start with 1 always. I'll put a 1 right in the middle of my thing right here. I'm going to put a 1 down there. I bring down the 2. 2 gives me 7. 7 gives me 0. 0 gives me -2. Now, that's not the right answer, nor is it an upper bound. So, Mr. Fontecchio, give me a logical guess above that number somewhere.
3.
Let's go 3. I'm going to try 3. I go 2. 2 gives me 6, gives me 11, gives me 33, which gives me 24. Am I right? Hold on. 33, 26, right? 26 times 3 is 60, 78, minus 3 is 75. That's an upper bound. So I'm going to make a little notation here for myself. You don't have to make that notation, but that means it's not above that number. And I have a sign change, right? So I want to know between which 2 integers it's going to be. I'm going to now try 2. Put a 2 in here. 2, 4 gives me 9. 9 gives me 18, gives me 11. Gives me 22, gives me 19. So I know between -2 and 19 there exists a 0. I also can anticipate it's well, it could be 3 halves, right? I could have 3 halves would be one of the ones I could be looking for in here. So it could be 3 halves, but it's probably irrational. Okay? So as it says between what 2 integers, I don't have to figure that out. All I'm going to do is I'm going to write between 2 and 3 there exists 1. That's it. That's all the notation right there. Remember, curved bracket means not counting 2 and not counting 3, but all the numbers in between. Somewhere in there is the right answer. I found 1 positive. Yes?
1 and 2.
There's 1. Oh, sorry. 1 and 2. Thank you. 1 and 2. Don't go with that. 2 and 3. It's not between 2. It's between 1 and 2, right? Because that's where the sign changes, right? Thank you. Larson didn't say it today. All right. I found a positive 1. Mr. Fontecchio. Should I now check 0 to see if there's 1 between 0 and 1?
Yeah.
Why?
Or I said no, so it would be negative.
All right. It's got to be a -1. I'm now looking at negative land. I could give a rip about positive land. I'm moving on. Okay. What's a logical number to pick at negative land?
-1.
-1. Why? Because we're lazy. I love -1. -1 is the best number ever because I'm lazy. -1. I put a 2 in here. -2 gives me 3. Gives me -3. Gives me -10. Gives me positive 10, which gives me 7. Now that is chilling because now I know I have 1 between these 2, don't I?
Yeah.
Has to be 1 there somewhere. Got to go find it. So now I'm going to pick what number? 0. Now, by the way, I already know it's between 0 and -1. You might not, but it's got to be negative, right?
Yeah.
Can't be between, it's -1 and above it, so it's got to be between -1 and 0, right?
Yeah.
But I'm going to do it just to amuse ourselves. 2, 2 gives me, 0 gives me 5, 5, 0 gives me -7, -7 gives me -3. Oh, look, it's between 0 and -1. So I got 1 somewhere between 0, oh, that's not right. -1 and 0. Since I just found my first -1, yeah, just found my first -1. Am I done?
No.
Why not?
You need another.
Need another one. And I need another one. What do you mean by that?
Oh, wait.
They're in pairs, right?
Yeah.
If I got 1, that means I got 2. Has to be there.
Yeah.
Okay? Watch out for that. I'm going to test that idea. And some of you are going to be like, I'm so good at my calculator, I don't need to do any more thinking. I can make your calculator lie to you so bad. Yes, sir.
So you do the lesser number first? Like
Yes, you always go for, a balance should always be from the lower number to the higher number. It's just our notation.
All right.
I'm not sure what I do if you flip those. Just do it that way. Okay, then I'm going to try, so I try a bigger number. What do you want to try, man?
-2.
-2? Well, that's not very, that's not giving me, what if, okay, whatever. 2, negative 4 gives me 1. You could be right. Negative 2 gives me negative 9. 18 gives me 15. Nope, that wasn't a good choice.
Negative 4.
Negative 4. Yeah, let's skip a few. Get down there a little ways. 2, I get negative 8, gives me negative 3. Gives me positive 12, which gives me 5. Gives me negative 20, gives me negative 23. That's a lower bound. And I got to switch.
So negative 3.
I got to check negative 3. Negative 3, 2. Negative 6 gives me negative 1, gives me 3, which gives me negative 4, which gives me 12, which gives me 9.
Negative 3 and 4.
So I got another one between negative 3 and 4. I don't know where it is. Oh, wait, I said that wrong. Negative 4 and negative 3. And there's my answers. There is one between that, one in this range, and one in this range. Or domain would be better phrase, because they're x's, right? Good? Everybody good? Everybody ready to enjoy this wonderful worksheet? Start grinding! Paper's over there in case you need it, because some of you do. Yes, ma'am. A physics thing? I don't know anything.
Oh.
It doesn't matter what the choice is. You always bring the last first 30 minutes. Bring it down.
What if you got an actual 0?
You just write down the number. Why?
You don't need practicing.
Well, it says between what two numbers? If you actually got a 0, then there would be no two numbers, right? It's just the number. Did you get 1 on 3? I did not get 1 on 3. So what happens?
1/2. I got 1/2.
Okay, why are you checking 1/2?
Because that was.
It's between what two integers? That's between 0 and 1. Why are you saying 1/2? You're doing rational root. I didn't ask you rational root. I'm telling you what two numbers. You're making this problem hard on yourself. So 0. So 0, I've got a 2. Gives me 0, gives me negative 13. Negative 13 gives me 1. 1 gives me negative 4. I shouldn't even know there's 1 at 1/2. What? Ha! Wait a second. She just found 1 at 1/2. She found 1 at 1/2. Why is there not a sign change here? There's 2 between 0 and 0 and 1. If you followed instructions, you wouldn't even know that. You'd have circled this and be done with it a while ago and not even know that there's 2 between the two. I don't expect you to catch that. If it goes up and back down, I expect you to miss it.
Okay.
Okay? I don't expect you to be checking rational roots anymore. Not for this assignment, right?
But don't you think to like get the factors that you divide the black?
I absolutely do. But the question isn't whether the actual numbers. What am I actually asking you to do? Between what two numbers does a root appear?
Oh. So we shouldn't be finding.
You shouldn't even be looking for the rational roots.
So we can just
You don't
do
care.
like 1, 2,
1, 2, 3, 4. Skip a few. Move around. Yes, yes, sir.
I'm just a little confused with like how you determine which ones are.
Whenever you have positive, 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 or negative, 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 you're done. That's an upper limit. And whenever it alternates, it's a lower bound. When it goes positive, negative, or negative, positive, negative, positive, I'm done. That's the bottommost it can be. At that point, picking bigger numbers makes it blow up.
So doesn't that mean there has to be a third one for 3?
Well, there's actually 2 between 0 and 1. But we don't know they're there because I didn't check between 0 and 1. Because I didn't use the rational root theorem. There's actually 2 there. It goes up and back down. That's why we miss it. Right, Gene Greco?
Yeah, I'm just kind of confused on how you know, you might figure out how many.
Ah! There is a 3 sitting right there. That 3 right there tells me I have 3 roots. Now, what types are they?
Yeah.
Don't know that, but I can say if there's sign changes. I go from positive to negative, that's 1 sign change. Agreed? 1. Another one, 2 sign changes. Now I'm doing a little count from Sesame Street right now. And then 1, that's 3 sign changes, right? If there's 3 sign changes, that means there's 3 possible positive roots. There's 3 positive ones. How many negatives can there be? 0. And they disappear in pairs, right? Because you can lose 2 imaginaries from either the positive or negative stack. Right? Does that make sense? 100%? You're good? All right. Yes, ma'am.
I have no idea.
So you found 1 even though there's 3. You know where you're going because.
Well, I would assume, here's the thing, and I'm wrong. If I did this correctly, the way I told you to do this, you would assume there's 2 imaginary ones that disappeared. I didn't find them. There's no sign changes, therefore there can be none. Now, I would really be suspicious about this zone right here, though. I mean, in real life, being a mathematician, knowing how numbers work, I went down to -1 and I made a U-turn. Is there any chance I dipped below and then came back up and had 2 roots? Now, I might be suspicious of that. But I would not expect a student where I say check to see where the integers are, I would not expect a student to look between the 2. Now, she found a half was 1. I guarantee there's another one there because it went down and back up, and that's why we missed it. Okay? Does that make sense? The other I would assume, now, if I had 1 missing, you got to go find it. Right? Because they disappear in pairs. Imaginary ones disappear in pairs because if you remember the graph looks like this, right? It dips down. Oh, just kidding. And so there's no roots there. And you lose 2 when you do that. And they're both imaginary. But if you're missing 1, go find it. You have to find it. You can't disappear 1. Yes, sir?
So you said the lower limit, you said
It's alternating.
yeah, so it's positive, negative, positive, negative.
Right.